According given situation, two plastic bags of negligible mass negligible है, placed 2 meter distance. It means the distance between the bags is a 2 meter. Each bag having 15 identical oranges. Suppose the mass of the each orange is m, so the mass of each bag is a 15 m. Now the 10 oranges moved from one bag to the other without change any distance. If the 10 moves means the remaining oranges in one bag is a 5 m, but the another is a 25 m. In the first situation, the force is proportional to the all distance are the same. The multiplication of the masses are the 15 into 15 in the first situation. In the second situation, the F2 is proportional to 5 into 25. So we can say F2 in the second situation force to the first situation force is equal to 5 into 25 divided by 15 into 15. So it is a 5 by 9 times of the initial. And the 5 by 9 times of the initial force means correct option is a fourth one. Situation, the A and B are the point above and below the Earth's surface and equal to the half of the radius of the Earth. And the acceleration due to gravity at these points is suppose the GA and GB. Here given situation, A point is at the height of r by 2 from the surface of the Earth, and the B point is inside the r by 2. That means G at the A is a gm upon r plus r by 2 means 3r by 2 whole square, and that will be the 4 by 9 times of the G on the surface of the Earth. And at the point B, which is inside the Earth, means G 1 minus depth upon radius, and depth is r by 2. That's why it is a G by 2 inside. Then G at the A to the G at the B, sorry, G at the B to the G to the G at the A. We know G at the B is a G by 2, while at the 4G by 9 is at the A. So it is a 9 by 8. The ratio is a 9:8. So the correct option is a second one. In this situation, the space shuttle starts upward from the ground with some initial velocity. Suppose the initial velocity of the shuttle is v0 at the height h. The acceleration due to gravity remains same, but the velocity of the shuttle is a vs. Then final velocity of the shuttle square equal to initial velocity, and suppose the acceleration of the shuttle is a, then it is a twice of a into h. Now the particle is released from the shuttle, then the velocity of the particle when it reaches on the ground with the same speed, that is a condition. Suppose the velocity of the particle at the ground is a velocity when it released from the shuttle is a vs square, as well as the speed on the ground is plus of twice of g, and the height is h. If you put the value of the velocity of the shuttle, which is a v0 square plus twice of a h plus of twice gh. Now the velocity of the particle, suppose the remains same, that means this term will be 0, and this term twice of ah plus twice gh equal to 0. That's why acceleration is equal to minus of g. It means the shuttle de-accelerate with the value of g. ऐसा होता है. तो ये पार्टिकल जो से किसी भी हाइट से ड्रॉप करे, हाइट चेंज होगा, दिस टर्म remains 0, and the velocity of the particle on the ground is equal to the initial velocity of the shuttle which is on the ground. So we can say correct option is the second. In this question the maximum height attained by the rocket का maximum height find करना है with the speed is a 60% of the escape velocity, means the velocity of the rocket on the ground is equal to the, we know the escape velocity is a root of twice of gm by r, but it is a 60% of this one, so it is a 60 by 100, so we can say it is a 3 by 5 time of escape velocity. And we know the velocity on the ground is suppose half m v square, and the potential energy is a g mm upon r, that is equal to minus g mm by r plus h. Then height attained by, यदि इसे सॉल्व करें तो height attained is a v square by twice g, that is a r, that is a result of the height attained by the any particle which is projected with velocity less than escape velocity, but it is very high, and the height is not negligible in comparison of radius of the earth. So the height attained by particle is not v square by 2g, it is v square r by 2gr minus v square. So the height attained by this rocket is a v square means it is a 9 by 25 2 gm by r multiply by r, that is a twice of gr minus v square is a 9 by 25, and we can write this is a 2gr because the escape velocity is a root of 2gr. So if इसे मैं इसी टाइप से लिखूँ, it is a twice of gr, then it is 18 by 25 gr square, and this is a 50 minus 9, 50 minus 18, 15 minus 18 is a 32, so it is 32 by 25, that is multiplied by gr, so 25 cancel with the 25 and g cancel with the g, r cancel with the this one, so it is r 18 by 32, so we can say it is a 9 by 16 times of the radius of the earth, that is a h maximum which is attained by the rocket. So here the h is negligible, then the height is equal to v square by 2g, but height is not negligible, then the not negligible in comparison of the radius of the earth, then the height attained by the any particle is a v square by twice of g, but it is multiplied by r and subtracted by v square. That is the result of this energy conservation, that is kinetic energy plus potential energy is equal to potential energy at the height h. So I think correct option is the third one. In this question the t is a time period of the satellite, the satellite's time period is a t, and the second thing is a orbital radius is a small r, it is the orbital radius. Then which of the following quantities does not depend upon the orbital radius? Then we know time period is equal to 2 pi r upon orbital velocity, and orbital velocity of the satellite is under root gm by r. So we can say time is equal to twice of pi root of gm, and that is a r, and root r is a r to the power 3 by 2. Then we can say t square is equal to 4 pi square gm multiplied by r cube, and according Kepler's law t square is proportional to r cube. Therefore the t square by r cube is a constant. This does not depend on the orbital radius. So correct option is the fourth one. A satellite is revolving around the Earth with the orbital speed is a v naught, and it is stopped suddenly. So according to the given problem, if satellite is at the height h, radius of the Earth is r, then orbital radius is equal to r plus h. So it means the height h से किसी पार्टिकल को ड्रॉप करें तो उसकी ग्राउंड पर स्पीड क्या होगा. So velocity of the particle on the ground is under root of 2gh, but this height is not negligible, so it is 1 plus h by r. Now this velocity is the satellite on the ground. Now this velocity in terms of escape velocity and orbital velocity, so we can say it is multiplied by r. So it is a velocity of the particle at this point is a under root twice of gr h. If we multiply by r in this term, so it is r plus h. Now this is a escape velocity is equal to, we know the escape velocity equal to root of 2gr or a root of 2gm by r, same thing. And the orbital velocity of the satellite is under root gm by small r. R is the orbital radius. Now this term h is a r minus capital R, and r plus h is a small r. So we can write this velocity at the ground is in a square root velocity, escape velocity square, and the term is a 1 minus r by small r. If we multiply by gm by gm को ऊपर नीचे मल्टीप्लाई कर दें, then we know gm by r is a escape velocity का square. gm by r is equal to escape velocity square by 2, and the gm by small r, orbital radius, is a orbital का square. Now velocity at the ground is a velocity at the ground is equal to 1 minus two by escape velocity multiplied by orbital velocity का square. Now velocity of the satellite on the ground is equal to, if we multiply by this term inside, then square root ve square minus 2 times of orbital velocity का square. So I think correct option is the fourth one. This 28th number problem. A satellite is of mass of m is launched from the Earth's surface to an orbit of 2r. So first of all, it is a shift in the orbit of 2r, then this orbit to 3r. So पहले इसे 2r में शिफ्ट करना, then इसे 3r में शिफ्ट करना. Initially ये ground पर है. So what is the total energy on the ground? Total energy on the ground is only in the form of potential energy. It is gmm by r. It is the first one. And second one, it is in the orbit of 2r, then total energy is a minus gmm by 2 into 2r, yani 4r. And third, that is a minus gmm upon 2 into orbital radius, that is the orbital radius is a 3r, means it is a 6r. So what is the work done in the first process? Work done in the first process is that is a 1 minus 1 by 4. It is a 3 by 4 of gm m by r, or we can say it is a 3 by 4 times of small m g into r. It is work done in the first process. And work done in the second process, when it is a orbit to orbit, that work done in the second process is it is a 1 by 4 minus 1 by 6. So 1 by 4 minus 1 by 6 is and the same mgr term is so it is a 2 by 24, it is a 1 by 12 times of mgr, and the second process is 1 by 12, and the first process is a 3 by 4. 3 by 4 and 1 by 12, so the correct option is the first one. In this given condition, two point objects of mass m and 4m initially at the rest, and separation is infinite. So at the infinite, total energy of the system is a kinetic plus potential, and we know the kinetic energy is 0 and potential energy is 0, that's why total energy also 0. So the total energy equal to the 0, so the correct option, total mechanical energy of the two objects is 0. First option is correct, but the relative velocity is square root of 10 gm by r. Kinetic energy of the object is 4 gm square by r when the separation is a small r. Then we know total energy equal to 0, then the separation is a small r. Separation is a small r means kinetic energy is equal to minus of g m 4m, and the separation is r. Then we can say it is a kinetic energy equal to 4 times of gm square by r. So I think third one is also correct. But in this situation, when the kinetic energy of the system is one of the mass is m with the velocity, suppose its velocity is velocity of the 4m is a v, then the velocity of the m is a 4 times of v. If we calculate the velocity, relative velocity, and the relative velocity is equal to 5 times of the v, then we know the half of m 4v square plus half of 4m v square, and that kinetic energy equal to 4g m square by r. This is the according energy conservation. Total momentum is equal to 0, 4 mv in the right side and 4 mv in the left side, and the separation is a r. Then we can say it is a 16 means 8v square plus 2v square is equal to 4g m by r. 10 v square equal to 4 gm by r by 10, 4 gm by r by 10. Then velocity equal to under root of 2 by 5, but we want to find the relative. Relative is a 5 times of v. Relative is a 5 times of v, means 5 से मल्टीप्लाई कर लेंगे इसको, then 5 से मल्टीप्लाई करने पे अंडर रूट जी एम बाई आर 25 into 2 by 5. So I think under root of 10 gm by r. So the correct option second is also correct. So all of these are correct. In this problem, the uniform spherical shell of mass capital M and radius r, then gravitational field intensity. Then we know in this one, gravitational field intensity at the inside, gravitational field intensity inside this shell will be 0. Now if we removed half part, then we know the intensity of this one is equal to this one, so both will be same. Therefore the net field intensity inside 0. If the small part is removed, small part is removed, then just inside the small part, intensity due to this small part is towards the part, and the larger part or a whole sphere is a inside. बोथ आर इन द अपोजिट डायरेक्शन, मीन्स यूँ कहते हैं कि छोटे वाले पार्ट के कारण, स्मॉल पार्ट के कारण जो इंटेंसिटी है जस्ट इनसाइड जो है वो इक्वल एंड अपोजिट है। और जस्ट आउटसाइड की बात करें हम, ये जो बात कर रहा हूँ जस्ट इनसाइड की, तो हम ये श्योर है कि स्मॉलर पार्ट का इंटेंसिटी उतना ही होगा जितना पूरे स्पेयर, बचे हुए स्पेयर का है, रिमेनिंग स्पेयर का है। बट जस्ट आउटसाइड की बात करें, जस्ट आउटसाइड की, तो इन दोनों का वैल्यू मिलकर, स्मॉल और लार्ज दोनों का मिलकर जी कैपिटल एम बाय कैपिटल आर स्क्वायर होगा। ये कहाँ निकाला मैंने, जस्ट आउटसाइड पर। और जस्ट इनसाइड पर जो है वो दोनों यदि हम अटैच करते हैं तो ज़ीरो आता है। इसका मतलब छोटा वाला उतना ही इफेक्ट करेगा जितना कि बचा और रिमेनिंग है। तो यूँ कहते हैं कि दोनों इक्वल है। अंदर की बात करें तो इक्वल एंड अपोजिट होने से ज़ीरो हुआ है। बाहर की बात करें तो दोनों का ऐड होने से कंप्लीट जी एम बाई आर स्क्वायर हुआ। सो द स्मॉलर पार्ट या लार्जर पार्ट का हटाने के बाद ठीक उस पॉइंट पर इट इज़ अ हाफ ऑफ द होल जी एम बाई आर स्क्वायर। सो द नियर द होलो पोर्शन मीन्स जस्ट हटने के बाद नियर द होलो पोर्शन का उतना ही होगा जितना स्मॉलर पार्ट का है, दैट इज़ अ होलो पार्ट, और दैट इज़ अ स्मॉलर पार्ट। या दोबारा मैं बात करूं तो इन दोनों को मिलाते हैं तो इनसाइड ज़ीरो होता है, आउटसाइड जी एम बाई टू आर स्क्वायर होता है। तो इनसाइड ज़ीरो होने का कारण यही कि स्मॉलर वाला पूरे लार्जर पार्ट के इक्वल एंड अपोजिट है। तो इसका मीनिंग दोनों का इफेक्ट जस्ट हाफ होगा। यदि ये पार्ट बड़ा भी करते हैं तब भी हम यूँ कह सकते हैं कि आई दोनों इक्वल पार्ट है, सेम है, हाफ पार्ट है, और ये भी आई जस्ट हाफ पार्ट है। ये दोनों मिलेंगे तो इनसाइड ज़ीरो होगा, इसका ना दोनों का इफेक्ट ज़ीरो होगा। सो इंटेंसिटी डज नॉट डिपेंड ऑन द साइज ऑफ द पोर्शन,